Have you ever wondered how computers recognize faces, translate languages, or even drive cars? The answer is deep learning, a powerful technology that helps machines learn from data just like humans. Hello and welcome. My name is Juma Shafara and I'm a data scientist at Raising the Village, an instructor at Data Idea. This year, I set out to help people become data scientists by covering data science concepts in a simple and intuitive way. And in this episode that I'm welcoming you is a beginner friendly introduction to deep learning. So, whether you are new to AI or just curious about how it works, this video will break it down in a simple and easy way. So, let's dive in. First, what is deep learning? Deep learning is a special kind of machine learning that allows computers to learn from data without being explicitly programmed. Think of it as teaching a child to recognize objects. After seeing very many pictures of, say, cats and dogs, they learn to tell the difference on their own. In deep learning, computers use something called a neural network to learn patterns from data. This is useful in many areas like recognizing faces in photos, like your Photos app or Instagram, translating languages like Google Translate, or even understanding speech, again, like Google Translate. To understand deep learning, we need to start from the most basic building block, the linear unit. A linear unit is a simple mathematical function that takes some input, x, okay, and multiplies it by a weight, w, adds a bias, b, and produces an output. The formula looks like that, how you are saying y is equals to a weight times x, an input, plus b, a bias. But what does this mean in real life? Imagine you're trying to guess the price of a house based on its size. Okay, the weight W represents how much the price changes with size, and the bias B adjusts for other factors other than the size. Okay, this is the foundation of how neural networks make predictions. A neural network is made by connecting many linear units together, like in this diagram. Each unit processes some information and the results are passed to the next layer. Think of it like a group of people working together. Each person has a small task and together they solve a big problem. The first layer, called an input layer, takes the raw data, okay, and the output layer gives us the final answer. The more layers we have, the more complex the patterns a network can learn. Now, so far, our neural network is just a bunch of mathematical equations. But to make it more powerful, we need something called an activation function. An activation function helps the network make better decisions by adding non-linearity. This means that instead of just doing basic math, the network can learn complex patterns. One of the most popular activation functions is actually called a ReLU, that is rectified linear unit, which simply says if the result is negative, change it to zero. Okay? Without activation functions, deep learning rather uh, wouldn't be able to recognize complex images or even understand human language. Now, we know that we know how a neural network is built, okay? In the previous section, let's talk about how it learns. Training a neural network means adjusting its weights and biases so that it makes better predictions. Imagine learning to throw a basketball into a hoop. Okay, you start by missing, but after many tries, you improve. The neural network does something similar. It makes predictions, checks how wrong they are, okay, and then adjusts itself to improve. The process it uses to improve is actually called gradient descent. A method called statistical gradient descent helps to speed it up. Now, when training a neural network, we need to be careful about two common problems: overfitting and underfitting. Let's begin with overfitting. Overfitting happens when a model memorizes the training data instead of learning actual patterns. Okay? It is like studying only past exam questions but failing to answer new ones. And then underfitting happens when a model is too simple and doesn't learn enough. It's like trying to play basketball without practicing properly. So, to build a good model, we need to balance between the two. Okay? To prevent overfitting, we can use a few techniques like early stopping. Early stopping refers to when we see that the model is starting to memorize data instead of learning, okay, we stop the training process. Okay. The other technique is dropout, where randomly turning off parts of the network during the training is done to make sure it doesn't rely too much on specific patterns. Then the final one is batch normalization. This is making sure each layer receives data in a standardized way so that learning is smoother. These techniques help ensure the models perform well on new data. Okay. Binary classification is one of the simplest tasks in neural networking, and this means that a model can decide between two options: yes or no, or spam or not spam. Okay, cat or dog. To do this, we use a function called the sigmoid function. So the sigmoid function converts numbers, okay, into probabilities. If a probability of a certain event, say a yes, is closer to 1, okay, we classify it as one category, that category. If it is closer to 0, we classify as the other category. Okay, so if the probability of yes is really high, okay, closer to 1, we take it to that category. If the probability of yes is really low, close to 0, we take it to no. The model is trained using what we call a loss function. And loss functions can include what is called binary cross entropy, which helps our network to improve over time. So, deep learning is changing the world from self-driving cars to medical diagnosis. Deep learning models are solving problems that we once thought to be impossible. Today we've learned how deep learning works, what a neural network is, how it learns from data, and how it can improve its performance. This is just the beginning. If you're interested in learning more, okay, just make sure you subscribe. I'll be uploading another video where we get to practice in code how this whole thing works. Okay, so stay tuned. Subscribe and like this video. Also share with your other friend that is interested in machine learning so that they don't miss out on this amazing thing. All right, thanks for now and bye.